Hi, I am Tomohiro Amemiya from the University of Tokyo, the Virtual Reality Educational Research Center. So today, I'd like to share my research on the resizing of peripersonal space for the cities for different step frequency of vibration at the source. So the main goal of this talk will be the how to find the how we can create a sensation of walking and how we can quantify the effect. Now I'm working on creating a sensation of walking without the body actual motion for seated users. So usually the sensation of walking in a VR was mainly created by a locomotion device for people who are actually performing a walking motion, walking action. But instead, I suggest a way to create sensation of walking for seated by combining the multisensory stimulus, multisensory information. In this case, I used the motorized the chair to move the user up and down with presenting vibration at the sole of the feet. And the full cycle was identical to that during the actual walking. So the participant will feel the kind of the impact on the ground, but with in a rocking on up and down motion. So usually the realism of a walking experience is examined through the subject to scales or questionnaires. Instead, I have focused on the size change of the peripersonal space or PPS. So as shown here, the previous studies have measured the size of PPS by the neural activity or the behavior and the behavior index. So the one example is the reaction time. So the rightmost figure shows the audio tactile interaction task to capture the critical distance from the participant's body where the approaching sounds affects the reaction time. So the results show that the tactile reaction time decreases when the walking on the treadmill. Here I measured the tactile reaction time without the actually walking, but the feeling a sensation of walking. So at first, what kind of the vibration was clearly induced the sensation of walking? So when we tested three kinds of the vibration, the walking sound, sinusoidal, and asynchronous walking sound vibration pattern. And we found out that the walking sound vibration is clearly, strongly induced a sensation of walking. It means the highest scores among the three conditions. And also we found that when we applied it at the sole of the feet, is clearly felt clearly induced the sensation of walking, but not at the forearms. So similarly we tested this effect using to measure the reaction time, and we found that a walking sound vibration facilitates an audio-tactile interaction even when the running sound, approaching sound was 1.2 meters from the participant's body, but not with the other types of vibration at the sole of the feet. So these results show that the inducing a sensation of walking without any body action would be sufficient to trigger the extension of the effect in PPS representation rather than the motor or proprioceptive signals. And this is the short summary of my talk. Thank you.